terms of getting from the raw data to the point cloud, LiDAR is what it is in a lot of ways. But then when it comes to what you do from there, it's changing as more, computer vision and AI start to come into it. I think some of the things that people will be doing with LiDAR in 5 to 10 years are not even really on our minds right now.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 329. How can LiDAR provide value to organizations? For that question, we turn to Lukas Fraser, LiDAR Specialist at the Geospatial Group of NV5. NV5 is a provider of engineering and consulting services to public and private sector clients. With offices nationwide and abroad, NV5 helps clients plan, design, build, test, certify, and operate projects that improve the communities where we live and work. At NV5, Lukas creates engineering-grade 3D mapping products from LiDAR imagery. He specializes in the collection and analysis of topographic and topo-bathymetric LiDAR data. He turns raw datasets into useful information, such as AutoCAD drawings and surfaces, GIS databases, or online interactive web pages. In this edition of the Drone Radio Show, Lukas talks about the process to collect LiDAR and image data with UAVs, how data is analyzed, and then how products are created that provide value to clients. But before we hear from Lukas, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how LiDAR provides value in the drone industry with Lukas Fraser of NV5. Let's pick up the interview where I asked Lukas to introduce himself.
My name is Lukas Fraser, and I'm the program manager in the Unmanned Systems Group at NV5 Geospatial.
Lukas, what is NV5 Geospatial?
We are the geospatial division of NV5, and we're kind of a combination of the NV5 legacy geospatial people and Quantum Spatial, whom NV5 purchased within the past year or two.
Is NV5 primarily a geospatial company?
No. So prior to the Quantum Spatial purchase, we had a relatively small geospatial presence. So it was all based around unmanned systems and drones. And then compare that with Quantum, they were one of the largest geospatial service providers in the nation, actually. So NV5 purchased them, coming from a more kind of traditional engineering and environmental background. And they purchased Quantum to really move into that space.
How long have you been with the company?
I've been working for the company for over 3 years now. Actually, the Unmanned Systems Group was an acquisition too. So there was a smaller company named SkyScene, which was founded by my two bosses, and NV5 purchased them to be the UAV group. And then one of the first thing they did was they hired me and a couple other people to come in and really grow their services.
So coming into NV5, what were some of the first things that you initiated to help them grow in that area?
Yeah, so I really took over kind of the LiDAR aspect of it. So we had they'd been doing UAV services for a while with just kind of imagery, working closely with, stereo photogrammetrists to get the imagery into those packages, and doing a lot of work with Pix4D and some other companies to really make sure that they had a great imagery product. But then they purchased a Regal LiDAR scanner, and they hired me to come on and kind of grow and expand the services that we offered from that. So in the beginning, we were just processing LiDAR and kind of handing it off to other divisions, but slowly we started to kind of take on more. So classification for the utility sector, topographic mapping for engineering clients. Then we got into web hosting and all kinds of other areas.
Now, I think most people have heard of LiDAR, but just in case, can you give us a brief overview of what LiDAR is and what it's used for?
So LiDAR stands for light detecting and ranging. A lot of people are familiar with sonar and radar. So LiDAR is very similar to those, except for that it uses light. So our LiDAR scanner sends out millions of pulses of light, and those go down to the earth and travel back up to the scanner. And the travel time is recorded. And that's how you end up with what we call a LiDAR point cloud. So instead of, what you might be used to if you're looking at imagery, which is just one kind of complete picture, the LiDAR, you end up with millions of different points, and they kind of combine to make up the earth, as we see it. And the great thing about LiDAR is that you can actually penetrate vegetation. So if you think about a wavelength traveling from our LiDAR scanner down to the ground, it can get multiple returns per pulse. So one pulse of light can travel down to the earth, and you might get a return off of vegetation, branches on the way down, and then finally, hopefully anyway, the ground. So we can extract different features that way. We can get rid of all the vegetation, we can make a bare earth model, or we can, even look at things like canopy heights or other valuable information that you can extract.
And does LiDAR give you the ability to see things in 3D?
Yeah, exactly. That's a great point, Randy. LiDAR point clouds are totally all in 3D. So they really make up the 3D aspect of our deliverables. We use our imagery for a lot of 2D stuff, and then we bring in our LiDAR, and we can use that to build all the 3D aspects of our deliverables.
In your opinion, how has LiDAR changed over the last several years?
Well, LiDAR's actually been around for a while, just the technology. It wasn't commercially available until maybe 20, 30 years ago. Don't hold me to that exactly, but those systems, in terms of ones that go into planes and helicopters, they've been getting more powerful and lighter too, to a certain extent. And, they've been able to do more. But the UAV, like as LiDAR relates to the UAV industry, it's only been since 2012 at the very earliest. I think that people have been doing that. So we've really come a long way. In the beginning, it was just the Velodyne pucks, the originally made for self-driving cars or other uses that people started attaching to UAVs. And there has been a lot of developments, and, there's new developments every year. So it's kind of an exciting time to be in this industry.
Give us a sense of your own experience with LiDAR.
I learned about LiDAR a little bit in university. I did the Geodesy and Geomatics engineering program in University of New Brunswick. I'm actually a Canadian citizen, and I worked for a mapping company here for 3 years, and we were doing large aerial collects. So, anywhere from a couple miles to up to like 10,000 square miles for government agencies. So I was really focused on just processing a large amount of data, making sure that it met all of the required accuracy standards, and then passing that on to the client. So mainly the LiDAR processing and not super heavily involved in producing deliverables. And then from there, I transitioned to NV5, where I really focused more on what you can do with that. So yes, it's important to have a good calibrated LiDAR point cloud. It's important to be familiar with national accuracy standards and guidelines, but also it's really interesting to see what you can do from there, because that point cloud is just the beginning. So that's kind of my evolution. I guess I had a bit of, educational background, then kind of really dove heavily into just pure processing for a couple of years. And then, compare that with the last 3 where I've been more focused on the products and things we're able to create from the point cloud.
What's it take for someone to master LiDAR?
Yeah, it just depends on what you're trying to do with it. It can be fairly simple. I know that there's more one-click, less complicated solutions that are becoming available these days. But it is still tricky, I will say. If you want to know how to compare your data set to all the national standards, for instance, it's hard to be able to dive into the data and truly extract all of the statistics and things that you need to be able to make sure that you're getting good data, first of all, and then to be able to manipulate that data quickly and efficiently and turn it into products. It is more challenging in my opinion anyway, than with just imagery, which is, another part of our workflow. But there's lots of materials out there online and schooling programs now that are kind of teaching more about it. So, it's opening up. People are interested. There's a lot of avenues that you could pursue to learn more about it.
What's typically needed from a hardware and software perspective to get up and running?
Yeah, so there's a lot of options nowadays in terms of LiDAR scanners. There's a bunch of different manufacturers that are all pumping them out, and even some lower cost solutions on the market. DJI, for instance, has started making their own LiDAR scanner. It truly depends on what kind of deliverables they're trying to create. I think the easiest is just, to collect it and then pass it on to your clients for them to produce the deliverables out of it. But I would recommend just, starting to look around and on LinkedIn, connect with some people and kind of read a bit more about what you're trying to do. Maybe get connected in with a good land surveyor. I know that's something that can be difficult for pilots who are really expert hobbyists or experts at collecting data, but maybe the accuracy side of things is a bit more difficult for them. So I would definitely recommend getting connected in with either, a land surveyor, a local one, or a company and learning a bit more about that side of things.
Okay, so what are some of the use cases for LiDAR?
NV5, geospatial on the whole covers a lot of sectors. So we have, the planes, helicopters, unmanned systems. So we have a really good range in terms of what we can accomplish. But specifically for me and us here in the unmanned systems group, our main clients would be in the utility sector. So that would be, we're doing power line surveys, whether they're trying to put in a new pole or tear down old ones, and they need to be able to get a really good, accurate location for all of their lines and to be able to assess them under different weather conditions, see what the sag and the loading is going to be like. So that's a large chunk of our work right there. And then we have more, companies similar to NV5 in the traditional engineering space. So since we can fly so low to the ground and get really high density data sets, we're talking, several hundred points per square meter in some cases. We can actually go in and map out features like curbs, retaining walls, basically all your traditional brake line features. We can map those out in 3D and create drawings in MicroStation or Civil 3D. And the great thing about our LiDAR too is that we're getting all of those features underneath vegetation as well. So we have the utility and the topographic. And then we do some other, niche services, like we do thermal imagery, multispectral. Occasionally we'll kind of integrate our topographic LiDAR data sets with remotely controlled sonar boats. We're looking into topo-bathymetric LiDAR, which is, LiDAR that can penetrate the water column. NV5 Geospatial has systems that can go on planes that can do this, but we're kind of looking at one of the newer Regal systems and what it would take to get that on a UAV. And finally, pushing data sets into the cloud for clients to interact with. So a problem that a lot of our clients had was that they just didn't have the tools or the techniques or the know-how to interact with some of the more difficult, programs like AutoCAD or even, standard GIS programs like ArcGIS or Q. So they were requesting an easier way to look at our data. So now we can actually push our LiDAR data sets, our orthomosaic images, our line work, and panoramic images all up onto our website. And clients can go on there and, just with a simple click of a mouse and a web browser, they can actually interact with our data sets and take all the measurements they need.
So your clients don't have to import the data into their own mapping systems then?
We do send all of our data sets to clients. So typically the ones that can use programs like ArcGIS, we send the data, they download it, they're good to go. But these are the clients that don't have access to anything. So they don't know how to use any software programs. They don't really know how to download them. We can just give them a link to our website where they log in their credentials, and then just using their web browser, they can interact with the point cloud in the same way that users, complicated software programs can.
What kind of scale can LiDAR be used at? Is it down to just a few acres, several hundred acres, many more than that?
Well, the United States has their 3D elevation program where they're trying to collect LiDAR for the entire country. So you can go pretty big with it. That's, of course, they're using planes for that. In terms of drones, we have projects anywhere from, half an acre, like basically as small as you can imagine, up to 40 square miles. I think 40 square miles is the largest project that we've completed to date. And that's kind of the great thing about it. There's no really project too small. And since our company also has helicopters and planes, we're not trying to force clients into doing projects that are too large for a UAV. So we're really trying to help them out and, get them the best services. But like I said, anything from, half an acre, a single property or a couple of blocks, up to 40 square miles, or, linearly for a utility project, we've done, I think 60 miles would probably be our largest one. That's kind of just getting into the point where it would be more, where we're starting to consider mobilizing a helicopter for that kind of collect.
What were some of the key goals that you had set at NV5 for your division?
When I arrived, my first goal, I guess, was to just instill confidence in the data. The drone industry on a whole, there's a lot of great professionals. People love talking about it and learning, but also can have a bad reputation, I guess, for giving people unrealistic expectations of the accuracy that we can achieve. We're not claiming millimeter accuracy here in our company anyway, because it's not really realistic. And that was my goal, was to set expectations and to communicate with, both internally with the land surveyors and with all of our clients, to make sure that they truly understood what we're able to achieve, and for us to prove it out with statistics. So using some of these national accuracy standards to really say, like, here's the accuracy we're achieving, and here's exactly how we calculated it, and this is why it actually makes sense statistically. So that was my original goal coming in. And then from there, I guess I was kind of just, open-minded to see where it would go. And it really kind of just played out with all these different kinds of deliverables. So, utility classification, that's something that, NV5 was already very familiar with, but we kind of started doing it more and more with our data sets. And then, creation of these 3D topographic maps with break lines, that was kind of something that we started doing early on too. And now it's grown into a really large part of our business. And the web hosting was something that I didn't really even see coming, but it was just created by client demand. So I would say I came in with kind of one main goal, but I kept an open mind, and it really just, clients and just from talking to people kind of dictated what direction we went with it. I think you have to be open-minded if you're in this industry.
Does LiDAR technology allow for creative solutions?
As a technology, a lot of the scanners created by different companies, they all utilize the same basic formulas and concepts. It's just a laser beam coming down from a scanner. They scan maybe at different speeds. They use potentially different wavelengths and whatnot. So I would say in terms of getting from the raw data to the point cloud, LiDAR is what it is in a lot of ways. But then when it comes to what you do from there, it's changing, every year as more, computer vision and AI start to come into it. I think some of the things that people will be doing with LiDAR in 5 to 10 years are not even really on our minds right now.
What was one of the last LiDAR projects that you worked on?
This was actually for a city in California, and we helped them with their drainage study conveyance plan. So it was around 100 acres. It was also fairly close to an airport. So that kind of brings in an added layer of difficulty. Our pilots have to have some communication with them to get approval to fly. And from there on, we collected, fairly dense, several hundred points per square meter. And then from there, we were able to go in, and I've already mentioned it a few times, but create a very detailed 3D map with all of the curbs and retaining walls. We went into people's, backyards via the data and really mapped out any 3D features that would be of interest. And then we used our imagery to compile all of the 2D features. So marking out houses, driveways, paint striping, basically everything that you could see. We mapped it out both in 2D and 3D using our imagery in the LiDAR. And then from there, the city was actually able to bring it in and figure out how the runoff was going to work in that area. So how all the water was going to flow, and how that was going to play into their storm drain system. And our data really played a critical part in both helping them create a very detailed map and also keeping people out of the road, because the way that they would have done this if it wasn't for our data would have been to send people out into the road and to pick up all these features kind of manually, I guess, which, creates disruption to traffic. You have to get permission to go into yards and in between houses, and it's very time consuming. So that was the one that we completed recently that I thought was pretty cool.
Plus, there's a safety factor, right? You don't have to have people out on the roadway with cars.
Oh, yeah. And that plays into a lot of our projects too. Just keeping people out of the road. This one, yeah, it made a difference. Nobody likes standing in the middle of the road. It was a fairly, quiet neighborhood, I guess. But some of the other projects that we've done, which are on really busy streets, picking up like mark out, for example, of underground utilities on the road, it's just the surveyors don't like going out and standing in the middle of a busy street. Nobody really likes to do that. It's a safety hazard. It's just very involved in terms of having someone check for cars all the time. So it can be a really big benefit safety-wise.
We hear a lot about digital twins in 3D mapping. Is LiDAR data also used in creating digital twins?
Yeah, it definitely can be. Different companies and different university organizations are using all kinds of different data to compile digital twins, but LiDAR is definitely a big part of it. You might be familiar with scan to BIM, which is kind of the term that we use to use a LiDAR technology either on the ground or via car or a drone to scan a building or, part of the built environment in high detail and then use that to create models. So LiDAR is definitely used for that.
Now, you mentioned earlier the United States topographic map. What other large-scale applications of LiDAR might we be familiar with?
Yeah, I can definitely list a few, but it's also worth saying before diving into this endeavor, they did a national enhanced elevation assessment, and they determined over 600 business cases for LiDAR. So it really ranges, and I don't even know the half of what people use it for, but some of the big ones would probably be flood risk management. If we're talking about topographic and topo-bathymetric, you can create a 3D model of the ground, both above and below the water. And so you can use that to really see how the water levels are going to change when the sea level rises or when there's a flood or some kind of natural disaster. Then they have infrastructure, construction management, agricultural precision farming. And I think forestry is a really big one too. You can use LiDAR to survey a large vegetated area. And then from there, you can extract things like tree heights and kind of try to differentiate between soft and hardwood and other really useful information for lumber companies as a part of their forest management plans. So that's just kind of to name a few, but if the users are interested, I would definitely recommend checking out the enhanced elevation assessment and looking into some of the cool use cases that they have there.
So what's next on the horizon for you and your team?
Right now, our group is really focused on automation. So using different programs like Python, for example, to really try to automate and really speed up our workflows. And then from there, we're just kind of also looking into different technologies too. So I did mention the topo-bathymetric scanner. There's a couple options available for those. So that's, penetrating the water column. We kind of want to get a system to do that, expanding some of our current offerings in terms of multispectral and thermal, and even potentially looking into hyperspectral. There's a lot of different things to work on. And also just coming up with a better integration for our LiDAR and camera system so we can collect more data all simultaneously. So we have a bunch of initiatives, I guess, that we're trying to decide how to prioritize at the moment. But like I said, the industry is just changing so fast and there's so much information to take in that sometimes it can be hard to kind of decide.
From your perspective, what's the LiDAR industry look like for individuals who are looking for a career?
I think it's a really great industry. It's got a lot of potential. Compare it with, when I graduated university where there was really no opportunity to now. Even in the past 3 years, just our department has grown from, I think we were 6, 7 maybe when I started, and now we're up to 15 and almost 20. So we're definitely growing, and I would recommend to anyone out there, if you're interested, look into it. Feel free to send me or anyone else that you can find on LinkedIn or anything a message, because it really is a great community. People like to talk about it. There's a lot of interest around it now. So, and clearly the business side of it actually supports it. So I know that was a concern at first, that maybe UAVs were, in terms of LiDAR, just a fad or just something that companies get excited about for a short time and then move on from. But I think at this point, we can pretty confidently say that they're here to stay, and the business case supports it.
And for my final question, Lukas, what message would you like to leave regarding the use of LiDAR in the drone industry?
It's a really exciting application for those business users who haven't considered it. I would say look into it. Maybe ask around and see if it could help improve safety or efficiency or bring costs down on your projects. And for young, emerging professionals into the market, I would say take a look. Maybe it could end up changing your life and then ending up being something you work in for the next couple of years.
That's it for episode 329 of the Drone Radio Show. I hope you enjoyed hearing from Lukas Fraser of NV5 Geospatial. I want to thank Lukas for taking the time to speak with me. If you want to learn more about NV5 Geospatial or want to connect with Lukas, check out the webpage at nv5.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.